In late 2025, astronomers around the world focused their attention on a rare cosmic visitor, 3I Atlas, only the third confirmed interstellar object ever observed passing through our solar system. Unlike typical comets that originate in the distant Oort cloud, 3I Atlas came from beyond our solar neighborhood, entirely born around another star and traveling for millions or even billions of years before briefly passing through our cosmic backyard. Its discovery sparked intense scientific interest and public fascination. What exactly is 3I Atlas? How did it behave during its closest approach to Earth? What did it teach us about other star systems? And perhaps most importantly, what mysteries does it leave behind as it now exits the solar system forever? In this video, we'll walk through 7 key areas. What happened during its closest approach? What we learned afterward? Where it's going now? The major scientific takeaways? The biggest unanswered questions? Ongoing challenges in interpreting the data? And finally, what 3I Atlas means for the future of interstellar astronomy. Closest approach to Earth. What actually happened? 3I Atlas made its closest approach to Earth on December 19, 2025. Despite dramatic headlines, it never posed any danger. At its nearest point, it remained hundreds of millions of kilometers away, far beyond the orbit of the Moon and even Mars. While it was too faint to see with the naked eye, this window represented the best observational opportunity scientists would ever get. Telescopes across the globe, coordinated to monitor the comet in visible light, infrared, ultraviolet, and radio wavelengths. Space-based observatories joined the effort, allowing scientists to observe the comet without interference from Earth's atmosphere. Crucially, the comet followed a hyperbolic trajectory, meaning it was not gravitationally bound to the Sun. This confirmed beyond doubt that the first Atlas originated outside our solar system and would never return. During closest approach, astronomers saw nothing that contradicted known physics. The object followed predictable gravitational paths, showed normal cometary outgassing, and exhibited no sudden accelerations or course changes. This period helped firmly establish 3I Atlas as a natural interstellar comet, not an artificial object or anomaly. What we learned from post-flyby observations after passing Earth's the first Atlas continued to be observed as it moved away from both the Sun and our planet. One of the most important findings was that the comet remained active even after perihelion, its closest approach to the Sun. Astronomers detected a persistent coma, the cloud of gas and dust surrounding the nucleus, along with evolving tail structures. One particularly interesting feature was a temporary ant-tail, an optical effect where dust appeared to extend toward the Sun due to viewing geometry and particle dynamics. These observations helped scientists better understand how interstellar comets respond to solar heating. Unlike many solar-assistant comets, 3I Atlas showed signs that carbon-based gases, rather than water, played a dominant role in driving its activity. This suggests it formed in a colder environment than many comets native to our system. Post-flyby observations also captured changes in brightness and gas production as the comet cooled. These changes are now being used to refine models of how cometary materials behave when exposed to stellar radiation for the first time in millions of years. Where 3I Atlas is now and where it's going, as of now, 3I Atlas is leaving the inner solar system. It is moving outward on a one-way trajectory, slowly fading as sunlight becomes weaker and its volatile materials freeze again. Eventually, the comet will become too faint to detect, even with the most powerful telescopes. From there, it will continue drifting through interstellar space, a silent messenger returning to the galaxy after a brief encounter with our Sun. Its exact future path will take it through a sparse region of space, possibly passing near other star systems over vast timescales. However, it is extremely unlikely to ever be captured by another star. In practical terms, humanity's observational relationship with 3I Atlas is over. What remains is the data, a permanent scientific record of a visitor from another planetary system. What we've learned so far, key takeaways. The most important conclusion is that 3I Atlas behaves like a natural comet. Its motion, chemistry, and activity are all consistent with known cometary physics. That said, it also revealed important differences between interstellar comets and those formed around our Sun. The dominance of carbon-rich gases suggests that planet formation in other star systems can produce bodies with significantly different chemical balances. Another major takeaway is just how valuable coordinated global observation campaigns can be. Never before had astronomers collected such a comprehensive dataset on an interstellar object. The lessons learned from observing 3I Atlas will directly influence how future interstellar visitors are studied. Finally, 3I Atlas confirmed that interstellar objects may be more common than once believed. Improved survey systems are now detecting them earlier, increasing the chances of deeper study in the future. What is still unknown or under investigation? Despite everything we learned, major questions remain. We still don't know the exact size and shape of the nucleus. The dense coma made direct imaging impossible, leaving only upper limits on its dimensions. The comet's full chemical inventory is also incomplete. While certain gases were detected, others may have been present in amounts too small to measure. Isotopic ratios, which could reveal details about the star system where it formed, remain uncertain. Another unresolved mystery is its precise origin. While astronomers know the general direction it came from, tracing its path backward through millions of years of galactic motion is nearly impossible. Finally, scientists are still studying how its outgassing changed over time and whether it experienced internal structural changes as it warmed and cooled. These details could reveal how durable interstellar comets really are. Ongoing challenges and cautions: interstellar objects like 3I Atlas push the limits of modern astronomy. They are discovered late, move fast, and fade quickly. This makes detailed study difficult, even with advanced instruments. There is also a need for caution when interpreting unusual features. Some early speculation, including claims of artificial origin, arose from misunderstandings of cometary physics. Continued analysis has shown that all observed behavior fits within known natural processes. Another challenge is separating intrinsic properties from observational effects. Viewing angles, dust dynamics, and solar radiation can create misleading appearances that require careful modeling to interpret correctly. Summary: where things stand now, 3I Atlas has completed its brief visit to the solar system. It passed Earth at a safe distance, revealed itself to be a natural interstellar comet, and provided an unprecedented opportunity to study material from another star system. We learned that interstellar comets can be chemically distinct, highly active, and scientifically invaluable. We also learned how much remains unknown, from their internal structure to their exact origins. As 3I Atlas fades into the darkness between the stars, it leaves behind more than just data. It leaves behind a preview of the future, where interstellar visitors may become regular targets of study, and where humanity begins to understand planetary systems not just as isolated worlds, but as part of a vast, interconnected galaxy. 3. The first Atlas was more than a passing comet. It was a messenger from another star, carrying clues about how planets and small bodies form across the galaxy. Though its visit was brief, its scientific impact will last for decades. Future discoveries will build on what we learned here. With better detection systems and faster response times, the next interstellar visitor may be studied even more closely, perhaps even by spacecraft. For now, 3I Atlas continues its lonely journey through interstellar space, while we remain behind, a little wiser, having glimpsed a small but profound piece of the universe beyond our sun. And that may be its greatest legacy, reminding us that the solar system is not closed, isolated, or unique, but part of a much larger cosmic story. Thank you for watching, and if you found this informative, please like and subscribe to the channel for more.